Today we're going to be teaching a Duelling DQN network to play Breakout using PyTorch. I'm going to assume that you're generally familiar with Python, deep learning as a topic, and a lot of the theory here. We're not going to be covering a lot of theory. This is really just a coding walkthrough. I also tend to take the approach that to get good at coding, you should read a lot of code, write a lot of code, and with that in mind, I will encourage you to code along with me here and build out the solution. I'll also encourage you to go and look at maybe a more full course in deep learning if you'd like to learn more about the topic. But for today, we're going to go ahead and get started. First off, let's cover briefly what we're going to be doing. We're going to be using the Atari Gym environment. We're going to be building a convolutional neural net to recognize images generated from that Atari Breakout environment. And then we're going to be implementing this bottom architecture where we have what's called a Duelling DQN network. That's where you've got half of the network showing the value of various actions you could take, and then you've got the other half of the network showing the value of the state as a whole. This is definitely worth reading up on. Again, we're not going to cover a lot of that here. To show you what we're going to be building, I'll show you my completed trained model. And as you can see, it's capable of playing the game. It's not going to play at any superhuman level. It'll hit a score of about 20 before it runs out of lives. There's a max of 5 lives here. But you can see that it's learned reasonably well how to play the game. This took about 24 hours of continuous training on a machine with a mid-budget GPU. So if you've got a standard, pretty standard gaming desktop that you're working with, you should be able to train one of these on your local computer. If you're working with a laptop or something, without a dedicated GPU, you may need to look at a cloud service to build something like this. So, but as you can see, we were able to get to so far about a score of 28 before it fell off. So, with the end goal in mind and a brief discussion of what we're doing, let's go ahead and get started. So, right off the bat, we're going to get rid of some of the default things that PyTorch is giving us, or that PyCharm is giving us. I'm going to import Gym. I'm going to import NumPy as NP. I'm going to import image from PIL. That's one of the libraries we end up using. And I'm going to import torch. All right, it's giving me an error on a couple of these. That's because I have not yet set up the Python interpreter for this environment. So in PyCharm, that is up under settings. I'm going to go to not editor. We're going to go to project and then choose Python interpreter. And then I'm going to choose Python exe here. And this is just an environment that I've already configured in general to work with PyTorch, NumPy, OpenAI's Gym environment, and some of the other things that I'm usually playing with here. So we can see that my list of imports has checked out. Our environment is good. I'm going to do something that I've found helps the environment not crash for me. This may be a PyTorch bug, or an OpenAI Gym bug, but if you end up needing this, OS environ kmp duplicate lib OK is an environment variable, and we're going to set that to true. Again, I don't have a lot of details on why this is necessary. For me, I've found the program will crash if that is not set to true, and that's been true across several different OpenAI tools that I've used. So we've set that. We want to go ahead and set the device that this is going to run on. So I'm going to say device equals torch.device CUDA 0, torch.CUDA.is available, else CPU. And that's basically going to say device is equal to your GPU, if you have a GPU registered, and otherwise it's going to be equal to your CPU. So now we get down to declaring our environment. So you can set up a gym environment fairly simply by just directly calling gym. We're going to need to override some of the default features, so we're actually going to be building out our own class that wraps the Atari Gym environment. And that lets us do custom rewards. It lets us fix some of the stutter problems in the default gym environment. So we're going to be doing a custom class. So I'm going to say environment equals DQN Breakout. And we're going to go ahead and pass it device. And it's erroring because there is no DQN Breakout class. So building this out is the next thing we're going to do. So I like to keep these things separate. We're going to do a breakout.py. Or actually, I don't have to put the .py. We're just going to say breakout. And we're going to start coding up our custom breakout class. So things we're going to need in here, I'm going to import collections, import cp2, import gym, import numpy as np, which is pretty standard. From PIL, import image, and PIL is just an image processing library, and then import torch. So our class is going to be DQN Breakout, and anytime you're wrapping Atari Gym, you always want to inherit from DQN wrapper, from gym.wrapper. So I'm going to say gym.wrapper, and then we're going to go ahead and put together our init method. So there are a few things we're going to want to accept here as arguments. One of them is our render mode, and we're going to set that equal to RGB array. A couple things to note here. For most of the Atari Gym environment, and it's different for different games, render mode human is going to show you something that you can actually see on the screen. Render mode RGB array is going to give you back an array of pixel information that your program can actually work with. I'm going to say repeat equals 4. We'll talk more about what that means later. And we're going to pass in device, and we're going to make the default device CPU. This is really a design choice here. You could leave all of these without defaults. I tend to prefer to go ahead and default everything up here so that the method will run, even if you haven't passed in all the parameters. But again, it is a choice depending on how you want to implement. So we've got our init method here. This is where we're actually going to stand up the environment. It would help if I spelled environment correctly. So we're going to say env equals gym.make. And we're going to be using breakout no frame skip v4 as our target environment. And we're just going to pass in that render mode equals render mode. We're also going to call back to the so if you're subclassing something, you always want to call the superclass, and to make sure that any variables, methods, etc. that are supposed to be set are. Otherwise, you're probably not going to subclass that correctly. So we're going to call super DQN breakout self dot init, and we're going to pass an env. So at this point, we have just a default environment. It's superclassed to init here. We're going to go ahead and override the step function. We're also going to need to override the reset function and provide a function for processing the observations. We'll probably get through part of the step function in this video and then leave some of the other parts of this class for a future walkthrough. So we're going to say step. So the step function in OpenAI Gym is basically you taking an action on the environment. So you're always going to take an action, and then it's supposed to return an observation or state, reward, done, in some cases truncated, and then info. We're not going to return truncated. We're going to do the simplified, return observation, reward, done, info. But we'll get to that in a moment. So I'm going to set. We're going to start capturing total rewards equal to 0. I'm going to say done equals false, because we want to break out of the loop whenever it's done. That's our goal there. And then we're going to be saying we actually need we said repeat here, so let's come back up to our init. We're going to go ahead and set self.repeat equal to repeat, so we can use it later. And we're going to say for I in range self.repeat. Now, first off, let's talk about why we're doing this. So there are a couple things we need to do here. One of them is, you don't actually want to make your agent think about every single action. A human wouldn't be reacting in less than a few frames. Keep in mind, most things are going to display 32 plus frames per second. So you don't actually need to react every single frame. So what we really want to do is take the same action 4 frames in a row. That's an arbitrary number. You could do more, you could do less. But we're going to be saying we want to take the same action for at least 4 frames. We're also going to be taking the max of the last 2 frames for each one of these. And we're going to be doing that because some versions of OpenAI Gym may not show every single piece of the screen every frame. They show them on alternating frames. And of course, if a human's looking at it, those frames are happening too fast to see. But an AI looking at it could perceive the environment differently depending on which iteration we're seeing. So we're going to take the last 2 frames and average them. So for I in range self.repeat, we're going to say observation, reward, done, truncated, info equals self.env.step. And actually, we need to come up here and actually we should not need to do anything special to use self.env. That should be okay. We're going to say total reward plus equals reward. So we're basically, we've got a total reward variable up here, and every time we cycle through, we're adding the reward from that cycle to total reward. This is necessary because of our repeating action. We're also going to capture the number of lives. So we should probably come up here. First off, when we first create the environment, let's set a default number of lives. env.ale.lives. And we want we actually need to look at the number of lives the environment has specifically, because it's not going to capture losing a life as a negative reward. As far as the environment's concerned, losing a life is just fine, and it only tracks scoring as a reward. Well, what that means when you're training your agent is your agent isn't going to learn that that losing a life in the game is bad. It might eventually learn it by proxy, because if you lose a life in the game, you can't score. But we want to help it along and give it some of that information a little bit more explicitly. So that is in the info column, and we're actually going to say current. Actually, let me step through how you would find that. So let's just start with printing info, and we'll get back to decrementing the current lives a little bit later. So that should be that'll be a useful thing to walk through. We're going to say in our for loop here, we're going to finish it then. First off, let's add a to-do, decrement lives. Always a useful feature if you want to highlight something as a to-do in Python. And then we're going to say self.frame. So we actually need a frame buffer. So what are we doing with these frames? Well, we need to store them somewhere. So let's come back up here, and we're going to say self.frame buffer, and that's just going to be a standard array here. Frame buffer dot append, and we're going to append our observation. You'll see me use observation in some places and state in other. From a practical standpoint, there's not a difference. From a theoretical standpoint, if something is considered a state, if you can see the entire state. Something is considered an observation if you are just seeing part of the state in an environment. So for any real environment, almost everything's always going to be an observation. So I really shouldn't be using state, but you will see that pop up occasionally in my code. And then finally, we're going to say if done, break. So if at any point in this range we get a done flag as a true, just go ahead and break out of the loop. So simple enough. We are then going to be doing, actually let's come back to that. Let's just go ahead and return. We're going to say I said we needed to average those frames, so we're going to say max frame equals np.max self.frame buffer -2. So we're basically grabbing the last two frames, and we're asking NumPy to give us the max between the two, and then we have to give it axis equals 0. We're also, and then we're going to say max frame equals max frame dot 2 self.device, which we took device up here, but we did not set it. So self.device equals device. All right. So then we're going to return max frame, total reward, done, and info. So at this point, we've overridden the init method and we've overridden the step method. Let's go see if we can actually use them. So I'm going to go ahead and say from breakout import star. And I'm a big fan of running your code early and often. You do not want to get too far into the project and find out you have a bug. All right, so everything seemed to go well so far. Let's go ahead and see if we can get some visual output, and then that will probably be a good breakpoint before we move on to the next video. So we're going to say render mode equals human. So hey, I want an environment a person can see. We're going to say for range 100. And first off, before you use an environment, you have to reset it. I'm going to say state equals environment.reset. We're not going to pass in any arguments. And we're going to say action equals environment.actionspace.sample. This is something the OpenAI gym gives you just to be able to, do random things in an environment. And then we're going to say state, let's see what we return. Total reward done info. So state reward done info equals environment.step. And we're going to feed it action and see what breaks. Oh, missing one required positional argument action. Let's see what we messed up. All right, and this is why you run your code early and often. So it looks like we passed an action here to our override function. We did not pass it in down here with step. All right. So this time we crashed out with numpy ND array object has no attribute 2. So it does not like that we're doing maxFrame.to self.device. Let's see what it doesn't like. So I think what we're going to need to do is do some object processing before it can get there. Let's go ahead and comment that out for now, and we will put that back in the next video. All right, and now we have a completely random agent that you can see playing the game. So I think that's enough for this one. In the next video, we'll pick up the rest of the breakout class and get this finished up and ready for us to actually start using it to learn. As you've probably gathered, this is going to be a fairly long multi-part series, so I hope you'll stick with me and have as much fun with this as I have building this project.